All right, so I want to talk about how to write the equation of a parabola if you're given a graph. So sometimes you might have a graph that is a parabola, and you want to write an equation that corresponds with it. And what I've done here is I've just given us the basic parabola. We call this the parent function, which is just y equals x squared. It's basically the most basic parabola you can get. And what we're going to do is I'm going to rewrite it in vertex form. So it's 1 times x minus 0 squared plus 0. So these are the exact same thing. This is vertex form. This is just kind of standard form, the way it's written. And they both represent this parabola that's graphed over here to the right. Okay, so the first thing I want to talk about is the vertex on a parabola. So the vertex is given by these two numbers right here. So generally, remember in standard, or not standard, sorry, vertex form, it's a times x minus h squared plus k, where h and k are the vertex. So the vertex is located at hk, which happens to be true. Specifically in our case, notice here the vertex is at 0, 0. The vertex is just the bottom of the parabola, or if the parabola opens down like this, then the vertex is that top point right there. So, with that said, in our case, the vertex is at 0, 0, so it made sense for us to put in 0, 0 for the vertex, okay? All right, so if you're going to write the equation of a parabola and you know where the vertex is, that makes your job a lot easier. Typically, I will write the equation of a parabola in vertex form. I just personally think that's the easiest. All you have to do is find the vertex and then find kind of how much it stretches vertically, which for a lot of parabolas is just 1, but sometimes it's a little different. Sometimes it's negative, sometimes it's fractions or decimals. Okay. Another thing I want to point out to you is that a parabola goes through a ton of points, in this case, all of which satisfy this relationship that y is equal to x squared. This is why we started off the year talking about functions. Functions are rules which assign outputs with inputs. In this case, the output is just the input number squared. You'll notice this if you come over and look at every single point on the parabola. Notice like the get my purple color here. Notice the purple colors. The purple dots over here on the graph are at -1, 1, and 1, 1. And it's true in both of these cases that the y value is equal to the x value squared. If you take -1 and square it, you'd get 1. If you take 1 and square it, you get 1. What about the blue points over here? So we're at -2, 4, and +2, 4. Is it true that the y value is equal to the x squared value? It is. Okay, that's what a parabola is. A parabola is a set of an infinite number of points where it's true that the y value is equal to the x value squared. And these don't just have to be whole numbers. Like there are decimal parts as well. So I don't know, well, I do know. If we wanted to, we could. Let's think about this for a sec. So I'm going to get a different color, like teal here. If we go right here, this point right here, that would be a y value of 3. So if the y value is 3 and 3 is x squared, then x must be the square root of 3. Plus or minus, okay? So this ordered pair right here would be the square root of 3, comma, 3. So there's an infinite number of these points along the parabola, and once you string all these points together, you get this really smooth looking curve here, which we call a parabola. Okay, you could do this point right here. This would be the square root of 2, comma 2. You could do this point right here, which I have no idea what that is. Maybe -1.5. Oops, sorry, this is actually negative square root of 3 there. So, but anyway, you get the point. If you have a point on the graph, it has to satisfy the y equals x squared. That's what I'm trying to say. Next thing I want to talk about is if the parabola happens to open up, then you've got a positive value of a. So if you look right here, this is your a. That means that if your parabola opens up, that means your a value should be positive. So if you're solving for a parabola that opens up like this and you get a negative a value, you probably did something wrong. If your parabola opens down, which means it would look like this, then this is going to have an a value that's negative, or in other words, we would say less than 0. So that's really important to know too. Okay, and then one last thing I want to talk about before we do some examples is I just want to look at the overall structure of parabolas. So for lines, so I'm going to talk about lines for a minute here. For lines, we go over a certain amount. Let's look at the vertex here. So we start here, we go over a certain amount, up a certain amount. And then if we were doing a line, we would go over the same amount and up the same amount. So if we're going over one, up one, we're going to go over one, up one again, 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 so on and so forth. That creates a nice straight line. What's different from lines when you're dealing with parabolas is when you go over, the amount you go up actually increases. So notice how at first we're going over 1, up 1, and then we go over 1, up 3, and then over 1, up 5. If you're guessing that we're going to go over 1, up 7 to get to the next point, you're exactly right. And so that's a structure that I want you to see in parabolas, okay? If you just have a standard parabola, x squared, where the a value is 1, then this actually happens all the time. We go over 1, up 1, over 1, up 3, up 5, up 7, up 9, up 11, so on and so forth, okay? If the a value changes, that will change a little bit. So if the a value is 2, we would go over 1, up 2, over 1, up 6, over 1, up 10. And if you just graph, you know, if you're not sure, just play around with it and you can kind of figure it out. All right, so let's look at an example. Number 1, write the equation of the parabola given the graph to the right. Okay, so we've got this graph here. Look at this. This is really nice. They gave us the vertex, and there are several points on this parabola that we can use if need be. So what I'm going to recommend we do is let's just write down the equation, the general equation for vertex form. So that is y is equal to a times x minus h squared plus k. Okay, we know the vertex, so currently we know that the vertex, which happens to be right here, is at 3, 4. So let's just fill that in. So we know that the vertex is going to be at x minus, and we're going to put the x value of the vertex in here, which is 3 squared. And let's actually color code that, orange. Squared plus the y value of the vertex is going to go right here, and we know that that is 4. Okay, so literally the only thing we have left to do on this parabola is figure out the a value. We know the vertex here. We know the vertex is at 3, 4. Now we just need to specify the a value that first of all flips this thing upside down. Normally parabolas are U-shaped like this, but this one is kind of more N-shaped. It's an upside down U. So how are we going to figure out the value of a? And this is where it's really important that you understand how graphs work and why graphs look the way they do and why certain functions have graphs that look the way they do. Okay, there are 3 variables in this equation, which if you only have one equation, which we only have one equation right here, and you have 3 variables, you're in big trouble. There is no way to know how to get one of those variables all by itself to solve to get a number if you've got 3 variables. We've got y, a, and x going on here. But what's interesting and helpful in this case is that we have points over here on the parabola. And so what this is saying is that it's saying, hey, at any point on this parabola, the y value should be equal to some unknown a value times the x value minus 3, and then you square that and you add 4. So what we can do is we can use our knowledge of an xy coordinate pair. I'm just going to randomly pick this one. You can pick any point other than the vertex. Any point other than the vertex you can pick and plug in the x and the y value, because you know that this equation has to hold given the x and y value if the xy value is on the parabola. If I pick this xy value right here, like 3, 2, that would now work. This point right here is not on the parabola, but this point at 2, 3 is on the parabola. So what we're going to do is we're going to use the point 2, 3 and fill that in for x and y. So we're going to use 2, 3, which we know is on the parabola, to fill in for the x and the y. So for y, instead of putting y, I know the y value in this specific case is 3. So I will say that 3 is equal to a, which I still don't know a, that's what we're going to try to find, times x. But be careful, don't put x in. You know that when the y value is 3, that the x value is 2. It could also be 4, but in this case, we're just going to use 2. Okay, so we're just focusing on this point right here. So we're going to plug in 2 for x instead of x. And then we're going to do minus 3 squared plus 4. So now I want you to look at this for a second. Before we had 3 variables, y, a, and x, and we weren't sure what any of them were. But what we've done now is we've taken this equation, which we know that this is true. If we could just figure out the a value, we would be done, and it would be this specific parabola. We know in general that this is the kind of equation we're going to need. We just need to find a. So what we're going to do is we're going to plug in an x value and a y value from the parabola. And when we do that, look at this. This is a number. This is a number. 2 minus 3 squared is just going to be negative 1 squared, which is positive 1, plus 4. So what we're going to do is we're actually going to solve this for a. So at this point, we've got 3 is equal to a times negative 1 squared plus 4. There's enough information here to solve for a. So this is going to be 3 is equal to, basically, if you have negative 1 squared, that's 1. So we're going to say 1a. I'm just going to actually say a. So 1a plus 4. And if you subtract 4 from both sides, you'll get that a has to be negative 1, because negative 3 minus 4 gives you negative 1. So a must be negative 1. So what does that mean? Is that our answer? No, that was just the a value. We just needed the a value for our final answer. So what would our final answer be then? Well, this right here was our equation, and we were almost done. We just needed the a. So let's fill in the a. So we're going to say that the final answer is going to be y is equal to negative 1 times x minus 3 squared plus 4. The 3 and the 4 came from the vertex. I'm going to zoom out just a little bit so you can see here. The 3 and the 4 came from the vertex. And then this negative 1 came from us using the vertex, filling in the vertex values, and then filling in the x and y values with an xy point that we knew was on the parabola. So this was pretty nice. They just gave us one of those points on the parabola. Okay, that's how you write the equation of a parabola given the graph to the right. Now, you could, if you wanted to, you could use factored form, like with these points right here. These are the x-intercepts. I just personally prefer using vertex form, so that's what I'm going to do. But theoretically, you could use factored form if you want. You could also do standard form, but you'd have to probably do like a system of 3 equations, 3 or 4 equations, and I'd rather not do that. So this is the easiest, quickest, most logical way that I can think of to do a problem like this. So let's look at another example. Okay, write the equation of the parabola given the graph to the right. This one is a little more challenging than the last one, really only because they didn't actually give us points, but we can find the points on the graph, right? So the vertex, I'm just going to say right now that the vertex, let's just write that down. The vertex right now is at, where is that? Negative 3, negative 5. Okay, and then let's find like another point that happens to be on the parabola. So it looks to me like that's a point right there. That's a point right there. We got all sorts of things we could use. We could probably use that one right there, that one right there. Okay, let's just use that first one I marked there. We could use any of those points and they would give us the answer, but let's use that one specifically. So I'm going to write the generic form, y is equal to a times x minus h squared plus k. And then I'm just going to fill in what we know. So we know the vertex, let's fill that in. So y is equal to a times x minus, the x value of the vertex is negative 3 here, so I'll fill in negative 3 there. And then the y value of the vertex is negative 5, so I'll fill in negative 5 there. So what is that? That's going to simplify down to y is equal to a times x. I'm going to actually say that this should be plus 3 because you have minus a negative. So we'll say plus 3 squared. And then plus negative 5 is the same thing as minus 5. Okay, now the only variable that we have that we're not sure about is a, and this is the exact same thing that happened last time. We filled in the vertex, so we got 2 out of the 3 pieces of information that we needed to know. To be able to write the equation of a parabola, by the way, you need to have the a, the h, and the k for vertex form. If you want to write it in standard form, you need a, b, and c. If you want to write it in factored form, you would need a, p, and q, based off of the other video that I did on those. Okay, so let's find a. The way we're going to find a is the exact same thing we did last time. We know that this is true given any point on the parabola. And by a point, I mean an x and a y coordinate put together. So what I'm going to do is I'm going to select this xy point specifically, which is at, let's see, where is that? That is -2, -3. So the xy point that I am particularly interested in is -2, -3. And I'm just going to fill in those values for x and y. So I know that y is -3. And that's equal to whatever this a value is, which I'm going to solve for, times x plus 3. But let's not put x. Let's put the actual value of x, which is -2 plus 3 squared minus 5. And now we're just going to solve for a. I'm going to move down a little bit so I have some room here. So this is going to be -3 is equal to a times -2 plus 3 is 1 squared minus 5. So that's going to be -3 is equal to a times 1. So let's just say a, and then minus 5. And then from here we would want to add 5 to both sides. And we would get that a must be -3 plus 5 is 2. Okay, so that's, whenever I box stuff in like that with a dashed line, it means that it's not my final answer, but it's definitely something that's going to help me get my final answer. So what's our final answer going to be then? Our answer here is going to be that y is equal to the a value here, which is 2, times x plus 3 squared minus 5. And oh, let's color code those for you. Sorry. So plus 3 squared minus 5. If you find it weird that this right here is plus 3 when the vertex was actually -3, that's because the general form is x minus whatever the h value is. So we're supposed to subtract this number and we're supposed to add this number. So that's why that one's -5 down here and that one's plus 3. Okay? All right, so that's your answer for that one. Let's do another one. All right, so write the equation of the parabola in standard form, not vertex form, with a vertex at 1, 6 that goes through the point 3, 2. So a lot of times what I'll do on these is I'll actually, since they didn't give us a graph, I'll just sketch a super simple graph of this, and it helps me visualize what's going on here. So let's go ahead and just do a simple XY coordinate plane here. And it says the vertex is at 1, 6, so we'll put that up there at about 1, 6 right there. And then it says that the parabola also goes through the point 3, 2. So 3, 2 is going to be about right here. And so it's saying that the vertex is actually up here and it goes through this point. That means, so now you have to decide, hey, is this parabola going to go kind of like this? In other words, is it going to look like that? Or is it going to look like this, opening down like this? And I'm going to say it needs to be the second one, because what we're saying is we're saying that this is the vertex right here. I'm just going to sketch it a little better. But it's going to open down like that. So, and we don't need a really amazing sketch here. We're just trying to get a basic feel for what this parabola looks like. Okay, so I'm just going to shade in these points again. So that point right there is at 1, 6, and that's the vertex. And then this point right here was the point 3, 2. So it just, we know that it happens to go through that point. All right, and so what made this problem a little weird at first was it asked for us to write this in standard form, and we've been doing these in vertex form. But what we're going to do is we're actually still going to solve for this in vertex form, and then we'll transfer it to standard form relatively easily. It's just going to add an extra step or two. Okay, so let's go ahead and actually write out our vertex form. Y is equal to something times x minus the h value squared plus the k value. And in our case, we know the vertex is at 1, 6, so let's just fill that information in. A times x minus 1 squared plus the y value of the vertex, which is 6. Okay? And now we're in a similar situation to where we were before. We know the x and the y value of the vertex, but the problem is we still have an equation. We only have one equation, but we have 3 variables, y, a, and x. So what we're going to do is we're going to pick a point on the parabola that's not the vertex. Don't pick the vertex. We're going to pick this point right here at 3, 2, and we're going to fill that in for the x and the y. So let's do that. We know the y value happens to be 2 here. And this is going to be equal to the a value, which we don't know, times the x value, which in our case is 3, minus 1 squared plus 6. And so I'm going to scroll down here just a little bit, and then we'll solve for a here. So let's see, 2 is equal to a times 3 minus 1 is 2 squared plus 6. So 2 is equal to, 2 squared is 4, so let's say that this is 4a plus 6. And then from here, let's subtract 6 on both sides. Not multiply by 6, subtract 6 on both sides. So we get negative 4 is equal to 4a. And then you just divide by 4 here on both sides. So you should finish with a is equal to negative 1. And I just put a on the left side, because saying that negative 1 is equal to a or that a is equal to negative 1 is the exact same thing. All right, so I'm going to zoom out here just so we can get a feel for where we're at. Okay, so we know that a is equal to negative 1. And what we're going to say now is we're going to write the equation of our parabola. So we know that y is equal to a, which is negative 1, times x minus 1 squared plus 6. All right? So this is vertex form. This is the answer in vertex form. So this is the parabola we want. So this is the parabola, but it's in vertex form. And the only problem with that is that they wanted standard form. So what we're going to do is we're just going to, let's zoom in here a little bit. We're going to take this parabola and we're going to expand it so that we can get it in standard form. So what I'm going to recommend you do here is go ahead and square this x minus 1 and leave everything else alone for a minute. So we'll have y is equal to negative 1 times, let's go ahead and actually multiply. If you do x minus 1 squared, you would get x squared minus 1x plus 1 if you distribute that. So that'll be x squared minus x plus 1. And then you'll add 6. And now what we're going to do is we're going to distribute this negative 1 to everybody. Well, actually, tell you what, let's simplify it. We have minus x in there. So let's simplify this a little bit. So this is y is equal to negative 1 times x squared minus 2x plus 1, and then plus 6. And then from here, we're going to distribute that negative 1 to everybody inside the parentheses there. So this is going to turn into negative 1x squared, which I'm just going to write negative x squared, plus 2x minus 1, and then we'll add our 6 after that. And from here, all we need to do is simplify. So we'll say y is equal to negative x squared plus 2x, And then if you have plus 1 minus 6, you really have plus 5. And so this right here would be the equation of that parabola up there in standard form.